Cold brew season's back. In this video, we're going to be talking about pulse settings. When it comes to using your pulse on your TIG welder, when you're new to it, a lot of people basically just stay away from it because they don't want to mess the machine up, they don't want to figure out what's going on. And really, when it comes down to it, there's 4 settings on the machine that you have to deal with that are pretty simple once you figure them out. And those 4 settings are the on-off switch, which usually may or may not have high and low speed pulsing. Then pulses per second, pulse amps or background current, pulse time or peak time. Now the names for these settings can vary from brand to brand, but they basically do the same thing no matter what they're called. I'll be using my little turntable for the travel speed in this video, so the only thing that'll be changing will be the settings on the machine. So let's get everything turned on and get started. Alright, we got everything turned on, ready to go, and I was thinking to myself we should do a control run of just straight current, and the machine set at 130 amps and the turntable set at 1 RPM. And I'm planning on not changing the amperage or the RPMs of the machine, so the only variables that'll be changing are the actual settings on the pulse. So let's do a control. I did forget to mention that this is 3/16 wall, 1.5" stainless pipe. This is the back side, and then here's the front side of the puddle. You can see the edges of the puddle are staying nice and even, the puddle's nice and even, just flowing nice and smooth. Typical straight arc puddle. Now we got the control weld done. Let's turn on the pulser, and hopefully you don't mind me doing a little freehand with the camera here, but on this machine it's all 3 settings on one switch, and it's off, high speed, and low speed pulse. So let's put it on low speed pulse, and this is the inside line of the pulses per second knob. A lot of machines will have 2 settings on the high speed and low speed if they have that as an option. If it's a digital machine, usually you just keep turning the knob or keep turning the button up until you get to the pulse that you want. On an older analog machine like this, a lot of times they'll have 2 lines, a high speed and a low speed. I don't know if we can see that or not because of the lighting, but you get the idea. So we're on low speed pulse. We've got it set to what the machine says, roughly about 4 pulses a second, but in reality it's more like 2 pulses a second. I set the pulse amps and the pulse on time to roughly 50% for this, just to kind of eliminate those variables. So we're dealing with basically just 2 pulses a second, 50% on time, 50% background time. So let's see what that looks like. So this is a pretty typical pulse. You kind of want to have it a little bit more drastic than this, but at 50% on time, 50% background current, you really get to see kind of what's going on here. And you can see it better from the back side, which is this one here. You can see where the arc goes full pedal, then down, and full pedal, then down. And right here I'm going to turn it down to 25% speed, just because it looks cool. And here are the results of those 2 welds. You can definitely tell a difference between straight amps and pulsed. Now for this next bead, what I'm going to do is the only thing I'm going to change is the low speed to the center high speed. And if you go off of what the knob says, and it'd be about 90 pulses a second, Is it 90 pulses a second? I have no idea. I really don't think it is, but we'll see what it looks like. And I did not change anything else on the background or the peak time. So this is only changing from low speed to high speed. So you can definitely tell that the pulse is on high speed, and it really just kind of agitates the puddle a good little bit. It does affect the width of the puddle. And remember, I'm completely floored at 130 amps, still at 1 RPM. And here's the back side of the puddle. And I'm going to slow it down again to 25%, and you can really see how the arc kind of pushes down into the puddle and comes back up, but really, really fast. Alright, so that's high-speed pulse. Where I like to use high-speed pulse is on very thin materials, like those 1/4 inch 035 wall tubes that I was welding. I was using about 350 pulses a second for those, and it really helped keep the puddle a little bit narrower and also controlled how much penetration I was getting. Don't need a whole lot of penetration with those because you're gonna burn through pretty much. So now, with pulses per second, me personally, I like about 2.5 pulses a second. When you start getting into the 3.5, 4, up to about 8 to 10 pulses a second, yeah, that'll put you in an epileptic seizure. It's not fun. You don't want to be looking at that all the time. So this kind of goes back to frequency on aluminum. If you are welding a whole lot of aluminum and the frequency is super annoying, you're not going to enjoy yourself. So if you can change the frequency of the aluminum to something that's relatively close to where you need to be, but it's not as annoying in your own ears, great. Same thing with pulsing. If 3 pulses a second doesn't bother you at all and you like the way that is, great. Like I said, me personally, I like about 2.5 pulses a second. I'm going to leave the pulses per second at 2.5, whatever it is on this machine. We're going to go back to low speed pulse. Now we're going to talk about pulse amps, or background current. So this is a percentage of the max amperage that it drops down to. So in hindsight, I should have set this to 100 amps. Would have made the math a little bit easier. So we'll use 100 amps as an example. If you have the max amperage set to 100 amps and you're floored on the foot pedal, and you've got, right now it's set to 50% background current or pulse amps, you're going to drop down about 100 amps to 50 amps, 100 amps, 50 amps. So that's what we've had it set to for the last 3 welds that we've done. So now the only thing I'm going to change is I'm going to drop this down to 10 to 15, whatever it actually is, I don't know. But the knob says a little bit above 10. So let's see what that looks like. So this is quite a bit more drastic with how far down the amperage is going to go. It's roughly from 130 down to 13 to 15 amps. So you're going to definitely get some very distinct freeze lines and also less heat input into the part. To me, this is a little bit easier to control and to see what's going on. And now we're going to slow it down to 25%, and you can really see how the amperage really backs off almost to nothing. So now you see, with lowering the background current or pulse amps percentage, it's a much more drastic drop in amperage, which gives you a more defined pulse. Sometimes that can be good, sometimes that can be bad. Now, if you're looking for a nice ripple effect, you want to be, you know, somewhere in the 15-20% background current, but every machine's a little bit different, so you have to really play with it and see which one works best for the machine that you're currently using. I don't usually go that far down when dealing with the background current. I like to have it, like I said, around 25 or so. But if you have it too high, if you have it like say at 80%, it's going to be such a minor pulse, you're really not even going to see it. It's not giving you the pulse effect that you're looking for, or the heat input that you're looking for, because when you're pulsing you can affect how much heat you're putting into the part, because it's hot cold hot cold hot cold hot cold. And when you look at the side by sides, you can really tell the difference between that control that we started with how wide that is versus all the other ones, and they're starting to narrow up a little bit. Remember, I'm flooring the foot pedal and keeping it at 130 amps the entire time, regardless of what it does. I'm leaving it at floored on both 1 RPM and 130 amps. So now I'm going to leave the background current where it was. So we're at 2 pulses a second, 2.5 pulses a second. The background current or pulse amps is going to be left at roughly 10 to 15%, whatever it actually is, I'm not sure, but you just saw what it was. And the on time was at 50%. So it was half the time was max amps, half the time was background current. So now I'm going to lower that down to 15% or so. And by lowering the pulse on time, or the peak time, that's going to make it so it's on the background current longer. So it's going to be low, high, low, high, low. Whereas if you raise the percentage of on time up, that would make it where it's longer on the high side and then short on the low side. So it'd be high, low, high, low, high. So that's how you can tell the percentage of on time or peak time. So let's see how it actually affects the weld. So you can see that it stays much longer on the lower amperage than it is on the high side. So this would be really good for thin material if you're just fusing it together or something and you want a very distinct freeze line. And this will also narrow up the puddle considerably because it's not spending a whole lot of time on the actual high side. So let's slow this down again to 25%. We'll definitely see how long it lasts on the low side versus the high side. It looks cool too. So here are the results. I had other pictures of this, but they were out of focus, so I wasn't able to use them. But as you can see, as you go along with this one, you can see the drastic difference that all of the different pulse settings are making with the width of the puddle and the actual look of the puddle. Amperage is still at 130 amps, still at 1 RPM. Only thing that changes is the pulse settings. So now let's set the machine to something that I would probably use for pulsing an outside corner joint. And I'm not going to really change the pulses per second because I like that pulse, but I'm going to move the pulse amps or background current. I'm going to move that up to about 25, a little bit below what this says is 30%. We'll see what that looks like. And the on time, I'm going to move that up to about 45%. So let's see what that looks like. Now to me, this is a much more controllable pulse speed. 45-50% on the background, so that it definitely drops down, but it doesn't go so far down that it's almost shutting off. On the backside, you can definitely see the distinct freeze line, and it always goes right out to the outside because I max at 130 amps on the foot pedal. And we'll slow it down again. You can really see how it changes between the background and the on time. And again, here are the results of all the welds that we did in this video. All of them welded at 130 amps with 1 RPM. Again, this is 1.5 3/16 wall stainless tube. You can definitely tell the difference between every single one of them, and just goes to show you that the different settings of the pulse can really affect the profile of your beads. Pulsing isn't that big of a deal. Once you figure out what those 3 settings are, it's really not that bad. And review, pulses per second is just how many pulses it's going to do in a second. Pulse amps or background current is how much percentage it's going to drop down from its max amperage. It's going to be 100 or 50%, 100 or 20%. It's just how far is it going to drop down. And then peak time is how long is it going to stay on its peak amperage. So if you can remember those 3 things, pulsing is no big deal. And also, if you've got one of these machines that is an older analog machine, just mark some Sharpie marks on it where you like it and don't worry about it again. If you have a digital machine, write down in a notebook the settings that worked really well for what material and how thick it was, and you never have to worry about it again. So hopefully this helped, and you turn your pulser on and give it a shot. Now these can vary from machine to sheet, from machine to machine. Now the names for these settings can vary from brand to brand.